a beautiful fall day in Falmouth, so thank you for joining us. As you know, all our talks are brought to you courtesy in part by sponsorships of Cape Cod 5, First Citizens Federal Credit Union, Martha's Vineyard Savings, and every book that we've got, including today's, is at a Cousins bookseller in Falmouth, so we hope you spend some time soliciting them. This is being recorded, just so you know. And Matthew Stanley, this is a little different kind of talk for us, but one I've been looking forward to, not just because I always find World War I to be fascinating, but Matthew Stanley is a professor at NYU. He teaches and researches the history and philosophy of science, and he went to Harvard. And this is a book that talks about how Einstein and the connections in science and the wider culture help shape the wider world. So, without further ado, and he's sharing his screen with us. Would you welcome Matthew Stanley?
All right. Hi, everyone. Thanks for joining us today. I'm really excited to be able to doing this kind of work. How's the screen share working okay? You see the book cover?
Yep, you're good.
You're looking good? Okay.
Yep.
All right. So we're here to talk about Einstein, right? And Einstein is the modern icon of science. His name literally means genius. Right? There aren't many historical figures whose name you can use to describe someone today, right? This person's a real Einstein. And it's one of the things I find interesting about that level of fame that Einstein has is that 101 years ago, no one knew his name. And then a few weeks later, he was one of the most famous people in the world. So I find it really remarkable how he goes from being an obscure academic to being recognized literally on every continent where there are people. And even further, I think it's interesting that he didn't have a whole lot to do with this sudden change. He became famous because he was in a particular time at a particular place. And that time and place was in Berlin during World War I, where he was blockaded and starving and isolated and persecuted. And it might sound like this wouldn't be conducive to a scientific revolution. But in addition to those misfortunes, he had one other ingredient that made all the difference. And that ingredient was his friends. Let's see if I can get the slideshow going there. And we'll get to meet all of these folks here as we go. I like to start the story not with the old sagely Einstein, who we recognize. Yes, looks like he's got all the secrets of the universe behind those deep eyes. And not the young heroic Einstein, looking dashing and irresistible to women as he was when he was young, but instead the middle-aged Einstein. It's the summer of 1914. You can see his hair is just starting to go gray. He's just moved to Berlin from Switzerland. He's actually coming back to Germany at this point. He was born in Germany to a secular Jewish family, and it was actually the highly rigorous and sort of militarized German school system that instilled in him his hatred of authority and his love of rebellion.
Dr. Stanley, if I can interrupt you 1 sec,
Yeah,
a couple of people said they can't see this screen share, so we have to reload this.
All right, how's that?
I can see it. I don't know. Is right on your chat if you can't see it. Just because.
It's behaving strangely for me, but as I'm screen sharing. All right, let me try. Stopping and starting something a little different. All right, is that any better?
I can see it.
Right, yeah, we need other folks to weigh in, huh? Better. Now looks good? Okay, cool.
Yep, we're good.
Thanks, everybody. Great. All right, so let me get caught up here. So for those of you who didn't see it before, this is the middle-aged Einstein who we're not used to thinking about. We're used to sort of the youthful rebel sitting in his patent office trying to overthrow physics, and we're used to the old wizened sage. But this Einstein is well known to maybe half a dozen people in the world. From his office as a patent clerk, he wrote a series of papers in 1905 that, amongst other things, helped create what comes to be the field of quantum mechanics. And this is of interest to theoretical physicists at the time, but essentially no one else. So no one outside physics really knows his name. And he's brought to Berlin to this new professorship position to work on quantum mechanics. That's what everyone else is interested in. But what he's interested in is his pet theory, that is the theory of relativity. And he's been working on relativity for some years by this point. As I said, he published a number of papers in 1905. 1905 is what's known as his special theory of relativity. It's special in the sense that it only applies to certain cases and special weird circumstances. And what he'd been working on since then was what comes to be called general relativity. This is supposed to be the extension of the ideas of relativity to all circumstances anywhere in the world. So he's hoping that once he gets to this new position in Berlin, where he doesn't have to teach and he doesn't have any administrative responsibilities, he can really hunker down and finish the theory he's been working on for about 10 years by this point. Unfortunately, one of the other people in Berlin is Einstein's mistress. So this close contact between him, his family, and his mistress means that his marriage implodes almost immediately. And he has very difficult personal times as soon as he gets to Berlin, and actually spends about a month sleeping on the couch of his friend Fritz Haber, one of the world's most famous chemists at the time. Soon after that, his family moves back to Switzerland, and he finds himself alone in his home with lots of time to work. So he actually is able to focus on general relativity a bit. Now, relativity, it's worth saying, is a very strange theory. This is the theory that describes the universe as being made up of a four-dimensional fabric of space-time, and that fabric can be bent and stretched and sometimes ripped. It involves bizarre things like clocks running slow and twins aging at different rates. And even worse, from Einstein's point of view, the mathematics needed for the theory is extremely complicated, far beyond what he was good at, in particular because in college he used to skip that particular math class. So when he discovered he needed this this particular set of mathematics, he went to meet up with his friend Marcel Grossmann, who is a professional mathematician. In fact, he was in that same class with Grossmann, and the only reason he passed the class was he stole Grossmann's notes. So as an adult, when he needs this help, as the story goes, he goes over to Grossmann's apartment and kicks in the door, and he says, "You have to help me or else I'll go crazy." So with Grossmann's help, he manages to whip the theory into sort of a draft form. It's coming along pretty well. It has serious problems still, but it's gotten far enough along that he's able to test it. And this is really important when you have a scientific theory like relativity that's so strange and so divorced from everyday experience that it's really helpful to have some kind of empirical test to persuade people that it's true, that it does relate to reality in some way. So Einstein, once he's able to get the theory into this kind of nearly finished form, there is a test that he suggests people can do to check and see if relativity is right. Now, one of the weird predictions of general relativity is that light is affected by gravity. That is, light doesn't actually go in straight lines in general relativity. but it's a very small effect. So you need a really powerful gravitational source like the sun to create any effect that can be seen, and even then it's very small. So Einstein's idea is that if we here on Earth, that's the blob at the bottom of the diagram, and we're looking at a star that appears to be right near the edge of the sun, the gravity of the sun will bend that ray of light coming from the star as it comes towards us. And from our point of view, it'll look like the star is in the wrong place, right? We've charted where all the stars are in great detail. So so if we look up in the sky and we see a star in the wrong place, very close to the sun, we could attribute that to Einstein's theory of relativity. The problem, of course, is that you can't see stars near the sun during the day because the sun is bright. So you can only do this test during a total solar eclipse, which of course are rare and happen only in particular places on the surface of the Earth. So luckily for Einstein, there was actually one coming up in August of 1914, and it was going to be in Russia, which is not that far from Germany. Einstein's not very good at using equipment, so he gets a group of astronomers to volunteer and go to Russia to go observe the eclipse and test his prediction to see if it's true. So at the beginning of August, this group heads over and crosses the Russian border. And I should say these kinds of scientific projects at the time were very common. That it wasn't at all unusual for different nationalities of astronomers to move from one country to another. So Einstein is back in Berlin, anxiously waiting to hear the results of this test. But the rest of the world doesn't care in the slightest. August 1914 is important for lots of other reasons, amongst other things, the outbreak of World War I. So this, of course, was the result of a long brewing geopolitical conflict, an arms race, escalating political tension, and all this gets triggered when Gavrilo Princip shoots the Austrian air to protest the occupation of Bosnia-Herzegovina. And this starts off a chain of war declarations among all of Queen Victoria's grandchildren, and the Great War has begun. Now, scientists, people like Einstein, for instance, and his friends who had just traveled to Russia to do this scientific test, thought they could keep themselves above the fray. That is, that they could keep the practice of science separate from politics. And a good example of one of those scientists is an English astronomer named Arthur Stanley Eddington. And Eddington was actually at an international scientific meeting in Australia for the British Association for the Advancement of Science when the war broke out. And it was really a remarkable scene where the English scientists toasted the health of the German scientists that were present, and the German scientists toasted the health of the French, and everyone declared that science was above all politics. It was particularly important for Eddington because he was not just a scientist with lots of international connections, but he was also a Quaker and a pacifist, and felt very strongly that the war was a horrifying thing, and he hoped that he could keep his professional life separate. Unfortunately, these high hopes were dashed almost immediately. So Einstein's friends who were in Russia were immediately arrested as spies, and their story of trying to test esoteric theory didn't go very far with the Russian interrogators. And Einstein is crushed that he finally comes so close to his theory being tested, only to have it interrupted by the war. Now, and this becomes the new norm. So scientists on both sides go into hostile political camps. German intellectuals, including many of Einstein's friends, his friend Haber, whose couch he slept on, these German scientists declare their solidarity with the German army. British scientists publicly say that Germans can no longer be trusted to do science. If they're willing to do something like torpedo the Lusitania, then surely they can't be trusted to report their experimental data. British and German scientists are attacking each other in print. Wilhelm Wien, a famous Nobel Prize-winning German physicist, says that he would no longer cite any English papers and tells people not to use English technical terms in any of their publications. There were special telegraph lines that had been used for transmitting scientific data across through different national borders. Those telegraph lines are cut. Scientific journals are no longer sent to so-called enemy countries. If you're a British scientist who happened to be working in Germany at the outbreak of the war, you were arrested and herded into a camp. If you were a German scientist working in England or Scotland, you were detained for the length of the war as well. Now, Einstein is horrified. His politics are far to the left at this point. He's a socialist and an internationalist. And he tries to speak up against the war. He's essentially the only person in the Prussian Academy of Sciences not supporting the war actively. He joins a peace organization. He tries to speak up against the war, but is largely ignored. Remember, he's not a very important person at this time. And his personal correspondence is really bittersweet in how he's experiencing these early days of the war. Because I love science twice as much in these times when I feel so painfully for almost all of my fellows about their emotional misjudgments and the sad consequences. We scientists in particular must foster international relations all the more and must distance ourselves from the coarse emotions of the mob. Unfortunately, we have had to suffer serious disappointments even among scientists in this regard. Now, Einstein, as a middle-aged man, no one was expecting him to go off and fight at the front, but even in Berlin, in his well-appointed circumstances, he felt the impact of the war essentially immediately. So Germany is surrounded by trenches on land and then the Royal Navy at sea. So the blockade means that everyone in Germany immediately begins experiencing food shortages. And in fact, something like 200,000 Germans die of starvation over the course of the war. Einstein himself is starving. He becomes very sick from malnutrition. And in fact, he only survives because he's getting food packages sent from friends and relatives in neutral countries. But his illness is quite severe. He loses 50 pounds in 2 months. His hands are always cold. He can't write well. For a long time, he's bedridden and continues trying to do his physics from bed in his pajamas. And he actually writes the fundamental papers of modern cosmology while under the blankets. But even as he tries to do his work, he feels politically and isolated intellectually in Berlin. All of his friends are supporting the war, and he does not feel like he can speak freely or safely. So whenever he can, he goes to the Netherlands, which is the neutral country abiding Germany to the northwest. And he has a small group of friends here. Here we can see in the lower left, Arthur Stanley Eddington, who actually hasn't met yet. This picture is from later. Paul Ehrenfest, with whom he loved to play music. Hendrik Lorentz, the older man in the front, something of a father figure for Einstein. And then in the back, the astronomer Willem de Sitter. So this little town in the Netherlands is the place where Einstein feels like he can actually say what he thinks, both in terms of politics and the war, but also about science. He isn't comfortable discussing his science among his patriotic friends back in Germany. So a strange thing happens that this is the place where he is really finishing up his work on general relativity. So essentially, these few people in the Netherlands are the only people in the world who know anything about the theory of relativity at this time. So if it wasn't wartime, Einstein would just take his papers on relativity and publish them in a journal, and they would be seen around the world immediately and become part of the scientific conversation. But the blockade stopped scientific papers just as thoroughly as that stopped armaments and food. So Einstein's ideas went nowhere except where he went personally. And really, even if his papers had gotten out, very few people in Britain or France, and by this point America, would be interested in hearing what an enemy scientist had to say about anything. So de Sitter, the guy in the back with sort of the pointy ears there, decides he's going to try and fix this. He is going to try to tell the world about Einstein's new theory. So he writes a letter describing general relativity and Einstein's work on it, and he sends it to the Royal Astronomical Society in London. And it so happens that the secretary of the Royal Astronomical Society at the time was Arthur Stanley Eddington, the pacifist we had met earlier. And I really can't emphasize enough how lucky Einstein was that Eddington was the one who opened that letter. There were very few British scientists who were willing to even think about a German theory at the time. But since he's a pacifist and an internationalist, he's really eager to hear what's going on the other side of the trenches. He's also one of the few people who understands the mathematics that it was written in, that math that gave Einstein so much trouble. Eddington had learned back in college because he did go to his classes. Now, De Sitter had chosen this one correspondent in Britain who was both willing and able to think about Einstein. Eddington is very excited about the science of relativity, but like Einstein, he feels isolated politically. He's surrounded by colleagues who are very pro-war and pro-empire, and are totally fine with never talking to German scientists ever again. But Eddington is deeply concerned that international science is not going to survive the war. All the kind of work he did depended on this kind of international cross-border work. So he works hard trying to convince his colleagues that it's the nature of science to not be caught up in national feuds. Some of the problems of our science can only be attacked by worldwide cooperation. The lines of latitude and longitude pay no attention to national boundaries. But above all, there is the conviction that the pursuit of truth, whether in the minute structure of the atom or in the vast system of the stars, is a bond transcending human differences. To use it as a barrier fortifying national feuds is a degradation of the fair name of science. And Eddington, I should say, becomes very good at making the case for international science and making the case for reaching across these national boundaries. And in large part, that's because he is part of this Quaker community that is working very hard against the war. So he takes the techniques that the Quakers use to protest the war, things like humanizing the enemy, making personal contacts, and showing the world as a better place than united than divided, and he does that in the context of science. So for instance, as his friends are saying that they can never talk to a German scientist again, he says, think not of a symbolic German, but of your former friend, Professor X, for instance. Call him Hun, pirate, baby killer, and try to work up a little fury. The attempt breaks down ludicrously. The worship of force, love of empire, and narrow patriotism, and the perversion of science have brought the world to disaster. So Eddington sees an opportunity when he gets this letter talking about Einstein. He realizes that Einstein can be a symbol of science reaching above the chasms formed by the war and showing that world-changing science depended on international cooperation. And Einstein was not only a brilliant physicist, but also opposed to his own nation's worst militarist excesses. So as a peaceful German, Einstein could be just what Eddington, a Quaker scientist, needed to convince his colleagues of the errors of their own patriotic ways. So relativity could be a project that let him show what was lost when science became consumed by wartime hatred. But remember, at this point, no one knew who Einstein was, and no one knew anything about relativity. So Eddington ends up devoting the next few years of his life to learning relativity, popularizing it, and getting the English-speaking world excited about it. And he does all of this with no communication with Einstein. The blockade is still on. It's not possible for them to talk to each other. And I should say, it's extremely difficult to learn relativity at this time unless you can talk to Einstein, because there are no textbooks. There are no papers. It's something that Eddington essentially has to figure out from zero. And like Einstein, Eddington realized that persuading people of the importance of relativity would require a test, again, some kind of physical proof that the theory was true. So he wants to do the same kind of eclipse test that had been attempted in 1914. He wants to see if the gravitational deflection of light happens the way that Einstein predicted. Now, as the next total solar eclipse at the time was going to be in May of 1919 in this arc across the southern hemisphere that you can see here. But planning for 1919 felt kind of fantastical. Would the war be over? Would it be possible for Eddington to travel to South America or to Africa? Could he get his colleagues to support a complicated and expensive expedition to test an enemy theory? Now, just as he was starting to make progress convincing his colleagues to support an eclipse expedition, he was suddenly in danger of being pulled from the observatory and sent to the front. The war had killed so many British men by this point that they were conscripting anyone who could hold a rifle, and that certainly included Eddington. But as a Quaker, he would refuse to fight. And there was actually a provision in the conscription law that Quakers could declare conscientious objection, but there weren't any rules about what was supposed to happen to someone who declared that they were an objector to the war. And the problem, so it was actually most likely that if Eddington declared conscientious objection, he would be sent to a prison camp where he would be doing hard labor. And many Quakers actually were tortured or died in these camps as well. So in order to prevent this, Eddington had to go before tribunals, into courts, to explain his conscientious objection to the war and explain why he thought he should not have to fight. And he had a great deal of difficulty, amongst other reasons, because people could not understand that he was both a scientist, and scientists seemed to support the war, and also a man of genuine religious faith. This idea that you could have a religious scientist who wanted to both do science and protest the war on religious grounds seemed very strange to many people. So it seemed that Eddington was in fact going to either be forced to go to the front or sent to a prison camp when a friend of his intervened. It so happened that Eddington was close friends with Frank Dyson, who was the astronomer royal, essentially the most important scientist in Britain. And Dyson intervened at the last second, making the argument that doing this test of Einstein's theory would actually be really important for British scientific prestige. That is, it would show that British science was the best in the world. So ironically, Eddington is allowed to do his expedition, which he sees as a great symbol of internationalism, on the grounds that it would be good for the British Empire. So Eddington was freed to plan for the expedition, but it still wasn't clear whether the war would actually allow it to proceed. Getting from England to Africa or South America would require running the submarine blockade that the Germans had set up around England. So the planners had to hope that the circumstances of the war would change. And in fact, in 1918, they did change. There was a massive German offensive, the Kaiserschlacht, that very nearly broke the Allied lines. But once it ran out of steam, the Allied counterattack defeated the Kaiser's armies in the field. And once it became clear that the Germans were not going to win in military terms, Kaiser Wilhelm flees Germany to the Netherlands on November 10th, and a new socialist republic was declared in Berlin. And of course, famously on November 11th, the guns finally fell silent. On November 11th, Einstein was actually scheduled to teach a class on relativity, and his diary records that class was canceled, quote, because of revolution. And he gleefully watches the collapse of this military state that he had been resisting for 4 years. And his socialist politics that had caused him so much trouble were suddenly a blessing. I am enjoying the reputation of an irreproachable socialist. As a consequence, yesterday's heroes are coming fawningly to me in the opinion that I could break their fall into emptiness. It's a funny world. And Berlin was literally in the throes of revolution. Einstein had to cross barricades. He negotiated for the release of university deans held hostage and helped set up principles of academic freedom in the new regime. So after November 11th, there was an armistice, but there was still no peace treaty. So the British blockade continued, and Einstein's health continued to decline. On the other side of the channel, Eddington was working frantically now that it seemed possible that the expedition could actually be carried off. The timing was such that it was just going to be possible to test relativity at the May eclipse. They would have to leave in early March. This was a long time before civilian aircraft travel, getting anywhere quickly. So even with the help of the infrastructure of the British Empire, traveling thousands of miles across a war-ravaged world was going to be challenging. They decided to send 2 teams. One would go to Sobral in Brazil, and one would go to Principe, an island off the coast of Africa. And Eddington would head the team that went to Principe. They had to suddenly prepare all of the equipment. They couldn't do any of those preparations during the war because of shortages of supplies and labor. And the way that you do a total solar eclipse observation at the time was this. You get a telescope or 2, and you lay them horizontally. Telescopes are very heavy, so unless you have a specialized mount, it's not easy to point them in the sky. And then you put a photographic camera at the far end on the right side of the picture that look down the telescope. And then there's a mirror. You can see the circular mirror on the left that reflects the image of the solar eclipse down the tube of the telescope, and then you take the photograph. And then what you actually do is you look at the photograph to see if the star is displaced in the way you're expecting. The photograph that they'd be looking, this is back in the era when photographs were on glass plates as well, so they're extremely unwieldy and difficult to use. The change they're expecting to see on the photograph is about 1/60th of a millimeter. So if you can take a second, get a sense of how that is, that's a couple of hairs width. It seems like a very small distance, but in fact, astronomers, even at the time, were very good at measuring that small distance. It wasn't easy, but it was something they did regularly. So one of the things that Eddington had to think about when setting up the expedition is what they were actually expecting to see. So Eddington put it this way. He said there were three possibilities from the expedition. One was Einstein's own prediction. Einstein predicted that the movement of the star would be 1.75 arc seconds. Don't worry about an arc second. What an arc second is, just a small distance. Eddington also pointed out that Newton's theory of gravity, which had sort of ruled the world for the last couple of centuries, was about half that. So that was possible too. And then it's possible that there would be no deflection at all, and neither Einstein nor Newton would be right. Now, as the story goes, Dyson is explaining these three possibilities to Cottingham, the guy who would be Eddington's assistant on the expedition. And Cottingham got it into his head the bigger the deflection, the better. So he asked, what if we get double the deflection? To which Dyson replies, then Eddington will go mad and you will have to go home alone. As they're preparing for the last days before they leave for the expedition, Eddington and Dyson spend a lot of time grooming reporters in London about the expeditions and their significance, so the results would be returned to a public eager and ready to hear about this titanic scientific battle between Einstein and Newton. So the astronomers hop on one of the very first passenger ships heading south after the end of the war. And they finally arrive on Principe. This was a little speck of a island, as I said, just off the coast of Africa. It's mostly covered in jungle and cocoa plantations. Interestingly, the cocoa plantations supplied the chocolate for the Quaker Cadbury factories back in England as well. So there's already a Quaker connection with the island. And in fact, it was the plantation workers that carried the astronomical equipment through the jungle and helped set it up to watch for the expedition. They get everything set up by the middle of May. It's taken them a full 2 months to get from England to Africa. And the astronomers begin practicing with their gear. One of the things they have to do is take photographs of the night sky before the stars are distorted by the gravity, so they can then compare it to how things change during the expedition. And it's hard to overemphasize how nerve-wracking the last few days before the eclipse were. By this point, there had been years of planning, months of journeying, weeks of physically and mentally grueling preparation, all without knowing whether the sky would be clear at the critical moment. As it happened, on the day of the eclipse in Brazil, the day started cloudy but cleared at the perfect moment, and the Brazil team telegraphed home that the eclipse was splendid. In Principe, though, May 29th saw a gigantic rainstorm. Local dignitaries huddled under the camera huts while the astronomers waited. The rain ended a couple of hours before the eclipse, but the clouds still remained. And totality began 5 seconds after 2:13 p.m., with the astronomers carrying out the machine-like photography process without knowing whether the clouds had cleared. One of the strange things about doing a professional eclipse observation is you don't actually get to watch the eclipse because you're too focused on the optical equipment. So as Eddington described it, there is a marvelous spectacle above, and as the photographs afterwards revealed, a wonderful prominence flame is poised 100,000 miles above the surface of the sun. We are conscious only of the weird half-light of the landscape and the hush of nature, broken by the calls of the observers and the beat of the metronome ticking out the 302 seconds of totality. By the end of the eclipse, the 16 photographic plates sat covered, holding the secrets of the stars until they could be scrutinized. But the event itself was over, and Eddington could take a moment to breathe. His telegraph back to Dyson was succinct, reporting through cloud, hopeful. Now, they developed the photographs in place, which those of you who are of a certain age to remember what dark rooms are like, imagine doing it in a dark room that you built yourself in the middle of the African jungle. And the photographs they got out of the 16 plates, only 6 showed the stars that they needed. You can see them marked in the upper right-hand corner of the image here. And another one of the plates shows the prominence flame that Eddington was referring to as well. So it was unclear whether those 6 plates would be enough, would give him enough data to actually come to a conclusion about the deflection of light. So Eddington spends every day hunched over the photos with his specialized measuring equipment, making fine measurements. And the effect he was looking for, as I said, was one that astronomers were used to looking for, but still tiny by any ordinary consideration. And even the measurements themselves weren't enough. They had to go through a process called reduction, which is when you account for interference and optical effects removed before they became real data. And this is extremely difficult mathematics. Eddington was legendary at how fast he could do calculations, but even for him, it still took time. So in the end, he writes home that one good plate that I measured gave a result agreeing with Einstein, and I think I have got a little confirmation from a second plate. So at some point in the first week of June of 1919, Eddington put down the pen he had been using for his calculations. Perhaps he rested his head in his hands. 3 years after he'd received de Sitter's first letter, a year after he'd walked freely out of the conscription tribunal, Eddington had his answer. He said, I knew that Einstein's theory had stood the test and the new outlook of scientific thought must prevail. And he later calls this the greatest moment of his life. But despite the solemnity, Eddington couldn't let the opportunity slip for a good joke, and he turned to Cottingham and quipped, you won't have to go home alone. This was just a matter of persuading himself, though. Persuading the rest of the world would take more work. It again took months to get back to Britain, where he again faced months of tedious measurement and calculation. The results, once they were all calculated and reduced, came out to be this. So if you recall, Einstein's prediction was 1.75, and the competing Newtonian prediction was about half that. And they got 3 sets of data from the 2 expeditions. One was 1.61, one 1.98, and one had a set of optical problems with the glass plate. So if you corrected for those problems, you got 1.52. So by the standards of a first test done in extraordinary circumstances, that seemed to be a firm confirmation for Einstein's prediction. And once he had the results in hand, Eddington presented the data to some private groups to see how it would go over. And since these went well, Dyson then scheduled a joint meeting of the Royal Society and the Royal Astronomical Society to present the results publicly. Eddington, of course, wanted to let Einstein know about this, but the blockade was still on, so he couldn't communicate directly. So Eddington sends a telegram to Lorentz in the Netherlands, and then Lorentz sends a telegram to Einstein. And of course, Einstein is delighted. And for the next month or so, anyone who walks into the Einstein apartment gets shown this telegram from Lorentz and explained its significance. One student reported the conversation as this. As full of enthusiasm, I exclaimed, how wonderful, this is almost the value you calculated. Quite unperturbed, he, Einstein, remarked, I knew that the theory is correct. Did you doubt it? I answered, no, of course not. But what would you have said if there had been no confirmation like this? He replied, I would have to pity our dear God. The theory is correct all the same. So many of the public versions of Einstein talking about these results have this kind of too cool for school feeling, but in his private correspondence, we can see how desperately thankful he is that the results came back as they did. This is him writing to one of his mentors, Max Planck. How deeply and how heartily pleased I was about the news contained in Lorentz's telegram. Thus, the intimate union between the beautiful, the true, and the real has once again proven operative. You have already said many times that you never personally doubted the result, but it is beneficial nonetheless if now this fact is indubitably established for others as well. Now, the public presentation of the results back in London were done at the halls of the Royal Society. One of the people in the audience there was the mathematician and philosopher Alfred North Whitehead, who described the scene this way. The whole atmosphere of tense interest was exactly like that of the Greek drama. There was a dramatic quality in the very staging, the traditional ceremonial, and in the background, the picture of Newton to remind us that the greatest of scientific generalizations was now, after more than 2 centuries, to receive its first modification. Nor was the personal interest wanting. A great adventure in thought had at length come safe to shore. The room was packed, elbow to elbow. Dyson takes the podium first and declared that, after a careful study of the plates, I am prepared to say that there can be no doubt that they confirm Einstein's prediction. A very definite result has been obtained that light is deflected in accordance with Einstein's law of gravitation. All the members of the observation team, including Eddington, got up and explained their observations and their data, whereupon the president of the Royal Society, J.J. Thomson, himself a Nobel Prize winner, declares, "This is the most important result obtained in connection with the theory of gravitation since Newton's day, and it is fitting that it should be announced at a meeting of the society so closely connected with them. If it is sustained that Einstein's reasoning holds good, and it has survived 2 very severe tests in connection with the perihelion of Mercury and the present eclipse, then it is the result of one of the highest achievements in human thought." The conversation that followed the formal presentation among the scientists was, to say the least, vigorous. Relativity was questioned, alternative interpretations of the data were presented. One particularly angry scientist rose and pointed to Newton's portrait, demanding that they move very carefully in modifying his theory of gravitation. The public reaction, though, was quite different. There were reporters at the meeting, as Eddington and Dyson had set up, and their report in the Times of London presented the greatest scientific headline in history: "Revolution in Science, New Theory of the Universe." Interestingly, just down the page was their report of the first Armistice Day observance as well, honoring the war dead. The follow-up article was titled "Einstein versus Newton." Remember, Newton by this point was essentially the scientific deity of Britain, whereas no one had heard of Einstein by this point. So he was a blank slate, and everyone wanted to know who this mysterious German was who had dethroned the king of British science. And Eddington was very careful that Einstein be presented exactly as he wanted, as a peaceful genius who repudiated wartime stereotypes. So he's described in that Times article as a man of liberal tendencies, and that during the war he protested against the German manifesto of the men of science who declared themselves in favor of Germany's part in the war. It takes a day or 2 for American papers to pick this story up, but then the New York Times, when they did, blared "Lights all askew in the heavens," that men of science were agog over the results of eclipse observations. And it's interesting to note, if you sort of go through and check, this is only the 2nd time that Einstein is ever mentioned in the New York Times. He really did come out of nowhere. Now, Eddington tries to capitalize on all of this publicity, and he begins a tireless tour to excite even further interests in the results. He gives public lectures and interviews, he writes magazine articles, all celebrating the scientific revolution made possible by the cooperation between recent combatants. And indeed, everyone wanted to talk about Einstein. And this public excitement finally made it possible for Eddington and Einstein, separated by the trenches, to communicate directly. In his first letter to Einstein, Eddington writes, "All England has been talking about your theory. There is no mistaking the genuine enthusiasm in scientific circles, and perhaps more particularly in this university. It is the best possible thing that could have happened for scientific relations between England and Germany. I do not anticipate rapid progress toward official reunion, but there is a big advance toward a more reasonable frame of mind among scientific men, and that is even more important than the renewal of formal associations. One feels that things have turned out very fortunately in giving this object lesson of the solidarity of German and British science, even in time of war." And Eddington was right. There was some amount of fortune there. Anytime when you're relying on weather and war, luck is going to matter. But more, the eclipse became what it was because of deliberate action. It was a symbol of German-British solidarity because Eddington and Einstein chose to craft it that way. It was not an accident that this became a great moment in scientific internationalism. Einstein himself liked to describe it in the same sort of terms. After the lamentable breach in the former international relations existing among men of science, it was in accordance with the high and proud tradition of English science that English scientific men should have given their time and labor to test a theory that had been completed and published in the country of their enemies in the midst of war. And all this fantastic publicity began what Einstein comes to call his Relativity Circus. There's unending press attention. He's hounded for autographs everywhere he went. Mail piles up at his home by the basketful. Everyone wanted to know more about this mysterious sage who had come out of nowhere to change the world. Einstein himself, already skeptical of any kind of authority worship, found it all faintly ridiculous. And he has a great way of describing this by an application of the theory of relativity to the taste of readers. Today in Germany, I am called a German man of science, and in England, I am represented as a Swiss Jew. If I come to be represented as a bête noire, a black beast, the descriptions will be reversed, and I shall become a Swiss Jew for the Germans and a German man of science for the English. So it's this moment as Einstein becomes world famous in the way we know him today. But his fame was not all positive. His fame as an internationalist, socialist, Jewish person draws the attention of the political right, and he's attacked as a Jewish internationalist. A group of anti-Semitic German physicists actually create a special anti-relativity society for the sole purpose of battling against his ideas. And this kind of political pressure spurs him toward even more political work, specifically with Zionism, and eventually leads to him being driven from Germany as the Nazis came to power, and Einstein comes to the United States as a refugee. But his sudden ascension to scientific celebrity by displacing centuries of Newton's dominance was squarely due to the timing and context of the war. One English scientist of the time described it this way: the war had just ended, and the complacency of the Victorian and Edwardian times had been shattered. The people felt that all their values and all their ideals had lost their bearings. Now, suddenly, they learned that an astronomical prediction by a German scientist had been confirmed by expeditions by British astronomers. An astronomical discovery transcending worldly strife struck a responsive chord. So very quickly, we get Einstein as a scientific saint. He bears a message of peace for a world tired of war. And indeed, relativity literally stemmed from a message from the heavens, from the stars, carried by the Apostle Eddington. But our image of Einstein as this aloof genius comes out of the devastating bloody years of war. It was only in contrast to those horrors that Einstein's triumph was so striking, a victory for pure thought, and scientific beauty, and world peace at a time when civilization itself seemed to be in peril. Relativity's sudden explosion and Eddington's zealous evangelism for it would never have happened in quieter times. It was because people from all across the political spectrum cared about their science that the world had just the right conditions for Einstein's sudden catapulting to fame. The horrors of the war and pacifists' reactions to them forged the intricate, fragile network that made relativity what it was. Without that network, the relativity revolution would never have occurred. The theory had few applications for decades, and even if it had been confirmed later, would likely have languished in dusty journals until cosmologists or GPS engineers realized they needed its delicate adjustments. Without the war, relativity would have just been one more theory, perhaps true, but obscure. Without the war, Einstein would be just one more name for bored school children to memorize. Instead, his name is now an idea, an icon, a personification of everything we want science to be. And the key to that was not simply Einstein's lone genius, it was his friends. So thank you all very much for your attention. I'd be happy to take questions if we have time.
Thank you, Dr. Stanley. It was fascinating. And if you got any questions, use the chat feature down below. It is kind of ironic that in a topsy-turvy world today, that a topsy-turvy world then allowed the theory we all know. I'll never claim I can understand it because I'm just not that good in science, but we all know what it is. What was it about this theory? And obviously, I think one of the things that you said is the power of friends. Is all this what is about this theory that caught Eddington's fancy? What made him so interested? And why isn't Eddington more
Well,
remembered?
those are really good questions, and they're important ones for understanding kind of how science works in all sorts of different ways. One of the things that Eddington was particularly excited about with general relativity was that general relativity, it's a theory of time and space, but it's how time and space combine in gravity. So, and this is the first real theory of gravitation that had been presented since the late 17th century, since Isaac Newton, essentially. So there were these long-standing puzzles in how gravity operated that Einstein seemed to be able to solve. And a lot of the features that many people don't like about relativity, say the complex mechanics, the kind of difficult epistemology, Eddington thought was pretty cool. That is, he thought it was pretty great to be able to start with questions about space and time and end up explaining why the planets moved as they did. He's an astronomer, so he's interested in things like the motions of the planets. And why don't we remember Eddington? There's a few layers here. One is that Eddington was a great popularizer of science between World War I and World War II. So people had Eddington's books on their shelves the way nowadays we have Carl Sagan or Neil deGrasse Tyson's books on their shelves. But those kinds of popular books do get left behind after a while, right? After a generation or so, the science is outdated and people stopped reading them. Eddington also had a very difficult late career. He did super important work in relativity and astrophysics, and this is still what people, if they know, scientists know his name, they know him for that. And then he had a unified field theory, a theory of everything that he worked on late in life that turned out to be a total disaster. No one accepted it. It was a completely awful theory. So many scientists remember him for that instead of his earlier work.
Okay. Did by teaming up, with Eddington, Coddington, by going and checking out his theory in 1919, certainly we all know about how the wounds that the Versailles Treaty left, and how there was no détente really for, maybe until after the World War II, but did at least the scientific community mend some fences between former combatants?
Not as many as you would like, or as people like Eddington and Einstein hoped. So during the war, while the fighting was going on, the Allied countries, chiefly Britain, the United States, and France, got together to make a new set of scientific organizations, a new group of international scientific organizations that explicitly did not allow Germans to join. So actually, at the same time, the same meeting where the Treaty of Versailles was confirmed, this new scientific community, the so-called International Research Council, is set up. And the idea is that the Germans, because of their behavior during the war, were no longer allowed to participate in international science. So it's literally in the founding statutes of the organization that Germans are not allowed to join in. But Eddington and others worked behind the scenes, and it takes several years before Germans are finally allowed. And actually, the International Research Council ends up imploding on its own. So some fences are mended, but it takes a lot of time and it takes a lot of effort.
Okay. We have a question here. Have the double deflection results been duplicated during another eclipse using modern equipment?
That's an excellent question. So the short answer is yes. And in fact, that quote from J.J. Thomson that I wrote actually ends with him saying, "And I look forward to the next test." So actually, American astronomers go and test this in the 1920s at 2 other eclipses, and they confirm Einstein as well. Now, it so happens that doing this test is extremely difficult, even with modern equipment. So at the total solar eclipse we had a couple of years ago, some astronomers tried to redo it again and actually did not get as good results as Eddington did. Partially that's because the circumstances in 1919 were absolutely perfect for doing the test in astronomical terms. So they're very difficult to do with an optical telescope, but now you can do it with a radio telescope anytime you want, because you don't have to wait for a total solar eclipse. So a standard part, if you take a graduate level observational astronomy class, you will do this test with radio astronomy. So yes, it gets confirmed regularly now.
What attracted you to this topic, and how do you research it?
Well, that's a good question. It goes way back to when I was a graduate student, actually. And I was interested in this question of how a scientist could have religious beliefs. And I wanted to find some interesting examples of how that worked. There's lots of older examples. Newton, for instance, is obsessed with theology and scripture his entire life. But I was interested in finding someone who did very modern work. So Eddington was an interesting case because he was well known for his religious beliefs, but also worked on quantum physics and relativity, sort of the defining features of modern science. Excuse me. So in researching Eddington, I was looking at the letters between he and Einstein. And I noticed that there were a bunch of other letters tucked into that same file, not from Eddington, but from other Quakers. And I couldn't figure out why this would be. And it turned out that after the armistice, but before the peace treaty, when the blockade was still on, people were still starving in Germany. And British Quakers organized work to bring food in to feed children in Germany that were starving. But they didn't have any contacts inside Germany. And it turned out that Eddington sets them up with Einstein as a connection of a professor inside Berlin to help make this connection. So I discovered quite by accident that there was this whole pacifist infrastructure at play in how these two scientists were talking to each other. So I had to go dig into the archives and try to find the letters of all the other people involved. A lot of these records get destroyed, both because of World War I and World War II. But fortunately, Einstein, since he becomes famous, saves everything, and I ended up putting together the story.
Okay. Anything you're working on next, or what's your next project going to be?
Well, I'm actually doing some research on how scientists talk about apocalyptic scenarios, things like asteroids crashing into the Earth and environmental collapse, and of course now global pandemics as well. One of the things I find interesting is that it used to be that if you wanted a story about how the world was going to end, you would go talk to a prophet or a priest or a scriptural expert, but now you go and talk to a scientist. So I'm interested in how it is that scientists get to be the people we talk to about how the world is going to end. And I should say it's a little bit difficult doing that kind of research these days.
Why didn't I have you for astronomy instead of who I am? I want to thank you very much for joining us today. Again, I wish you would have been able to come to Cape Cod directly, but
yeah, me too.
you know, since we're talking about the end of the world, we're living through a pandemic. We're doing the best we can. So
that's right.
Thank you very much for joining us. Good luck with this book.
Thank you.
I hope that the NYU school year goes well, and that the asteroid doesn't hit before the only thing in 2020 hasn't happened. Thank you everyone for joining us. Thank you, Dr. Stanley, and good luck everyone. Thank you and good luck with the book.
Thank you all so much.
Thank you.